Well, what I want to do now is look at the more recent period. So the observations of carbon dioxide began in 1958, as I've mentioned before, and just wanted to say a little bit about what's happened in this recent period. Back in the late 1950s, the carbon dioxide concentrations were about 315 parts per million, and they are now 415 parts per million. We're increasing roughly 2 parts per million every year, or about 1.5%. You'll notice that there's kind of an up and down movement here every year. In the northern hemisphere, as spring and summer come along and vegetation starts growing and trees grow and develop their leaves and so on and absorb carbon dioxide, the amount in the atmosphere decreases. And then in the northern hemisphere, where most of the land mass is, when fall and winter come along, then the reverse happens. The leaves fall, things start to rot, and that increases the level of carbon dioxide in the atmosphere. But you can see that there's just a steady upward march here. Despite, I might add, all of the commitments that have been made in the last couple of decades about reducing emissions. You can see that that's essentially come to nothing. Well, what are the consequences of this in terms of temperature? This is often called global warming. So let's see some temperature data. Temperatures around the world started to be collected in a systematic way in 1880. So exactly what was happening before that, we can't measure directly. So the best estimates that there are, there's estimates, as you can see, by a number of different organizations, probably drawing on slightly different data sources, look something like this. So let's just see what this means. This 0 here is representing the average level of world temperature between 1951 and 1980. You can see that there was kind of a period there where the average temperature didn't seem to increase for some reason. So this is looking at differences between the average temperature over those 30 years and the temperature in the year in question. So you can see that from 1880 through to about 1940, the average temperature was less than it was between 1951 and 1980 by sort of varying between about 0.2 and 0.5 of a degree Celsius. And since that time, since 1980, you can see that there's been a steady upward trend, sometimes up, sometimes down, but the trend is obvious. And of course, as long as there's a net addition to the stock of greenhouse gases, we could expect this temperature increase to continue. So what we have to look at a little bit later is just how far could that go and what might the consequences of that be. If we look at the most recent years, we now have data for last year. The 10 hottest years on record globally are these ones here, and as it notes, the last 5 years have also been the hottest. These temperature changes here are relative to those between about 1880 and I think the early 1900s. So we're now about 1.25 degrees Celsius warmer than at that period. Well, what are the consequences of climate change? I'll just briefly run through some. This is not going to be an exhaustive list, but I'll just mention some of the major ones. Many of these things will already be familiar, but let's just refresh our memories. Everyone's aware that there have been more powerful hurricanes and typhoons in recent years. That comes about as a result of warmer surface waters. So much of the world's oceans have been instrumental in absorbing a lot of this excess heat. And to the extent that that leaves the surface of the ocean warmer, that allows these more powerful storms to develop. Climate change also includes changes in rainfall patterns. So some places will get a lot of extra rain, which could lead to flooding and that sort of thing. But other areas are going to experience drought. Some areas that are currently being used for agriculture will turn into deserts and will not be useful. I've already mentioned melting glaciers. Ice sheets and glaciers. Glaciers, I guess we often use that term to describe ice that's in mountain ranges, and those are rapidly melting as well. They provide very important drinking water and water for agriculture in many parts of the world, particularly South Asia. The sea level is also rising simply because the oceans are absorbing heat, and the hotter a liquid is, the greater its volume, as you're probably well aware. There are forecasts as well of deadly heat waves, perhaps coming as soon as towards the end of this century. So these are not just heat waves, but also combinations of heat and humidity, which can be such that just sweating is not going to allow you to cool your body, because if the air around you is humid enough, that sweat is not going to evaporate. So these could be heat waves that could kill someone if they were outside for more than a few hours. There's already species extinction taking place, as you may be aware, both in the land and in the oceans. Coral reefs are expected to be destroyed by the middle of this century, unless something miraculous happens. The oceans are also getting more acidic. I mentioned that oceans absorb carbon dioxide, and that forms an acid as that happens. So as the oceans become more acidic, as I think I mentioned in an earlier lecture, it makes it, among other things, more difficult for creatures that form protective shells to do so. Climate change is also going to affect air and ocean currents. There's been considerable discussion, for example, about whether the so-called Gulf Stream that takes relatively warm water from the Caribbean up across the North Atlantic and helps keep northern and western Europe relatively warm, There's been some discussion about whether that's going to be disrupted, in particular disrupted because of the great flow of fresh water that's coming off Greenland. Should that happen, that would mean a major change in climate in Europe. Well, what else to add to this dismal list? Disease, much on people's minds these days, is going to increase simply because the insects that carry things like malaria and dengue fever are going to have the territory in which they live greatly expanded. Okay, well, that's a list of possible negative effects of climate change. I'm going to end this little slideshow with a question. I've gone through all this, showed you the scientific evidence, the increase, sort of steady increases in carbon dioxide levels, increases in temperatures, and we've just briefly reviewed some of these unpleasant consequences of climate change, which are only going to get worse during our lifetimes. How did you feel about that? Did you feel any emotional reaction? Did you feel alarmed or concerned? Or did you just ask yourself, I wonder what he's going to ask on the test or the quiz? And then kind of carry on, be prepared to carry on with life as normal. Well, this fellow here, Per Espen Stoknes, who's an economist at the Norwegian Business School, has written a very interesting book, which I'm reading right now, called What We Think About When We Try Not to Think About Global Warming. And I'm drawing this to your attention because the psychology of climate change, I think, is absolutely critical in determining whether we're going to act to do something about this or whether we aren't. So that's something that I think you should give some thought to. I have posted a talk that he's given on our D2L site, and I think you would find it very interesting to listen to. Well, in the next set of slides, I'm going to turn to thinking about what economics has to say about how we should respond to climate change and how people have responded.